Hi everybody, this is 3.4 linear and angular speed. If you look this up on page 121 in the textbook, you will see that when you're talking about linear and angular speed, you can consider the following. The human joint that can be flexed the fastest is the wrist, which can rotate through 90 degrees or pi over 2 radians in just a fraction of a second, 0.045 seconds. This is especially while holding a tennis racket. You can go this quickly. The angular speed of a human wrist in swinging a tennis racket can be modeled by this equation, where you have this W equals the theta over the time. Okay, you can put in the information that is given above, 90 degrees, you've got the time, and you can see that your arm can move about 35 radians per second, or in this case, the wrist. Okay, so we're going to be using these formulas. You can also see a couple other formulas that the book uses. Again, this is page 121. This is your angular speed formula, which we'll be using, and then also your linear speed formula. So we'll be using those two formulas today. Okay, so this is omega, and this is the reason, this is the uppercase omega. If you're kind of thinking that's not what omega looks like, uppercase omega looks like this, lowercase omega is this W. So omega equals theta divided by the time. If you're looking at the linear speed, your V equals the radius times the omega. So let's look at example A. This is number 5 out of your book. We're going to use this formula, omega equals theta divided by the time, to find the value of the missing variable. So I'm going to start by plugging in what is given. The omega is equal to 2 pi over 3 radians. We don't know theta. Do you see how theta is not given here? So I'm going to put in theta like that. And I'm dividing by the time, which is given 3 seconds. There are lots of different ways to solve these algebra problems. In this case, to me, it looks like the easiest way to do this would be to cross multiply. So I'm trying to find theta. So I'm going to multiply 3 times theta, which is 3 theta. Next, I'm going to multiply the 2 pi times the 3. So 2 times 3 will be 6 pi. I want to get the theta by itself, so I'm going to divide by 3. 3's divide out. 6 pi divided by 3. 6 divided by 3 is 2 pi, so I can just write 2 pi radians. Theta is an angle, so I can say 2 pi radians. Okay, using the same formula, again, the formula is omega equals the theta divided by the time. So omega, that is our linear speed, and in this case, it's 5 pi over 27 radians per minute. Theta in this case is given. Theta is 2 pi over 9, and we're still dividing by time. Okay, now this time is kind of weird the way that this t is kind of at the bottom hanging out here. There's lots of different ways that you could do this. You could cross multiply the 5 pi times the t. You could multiply these two together, but I'm going to have to work with a fraction then. So what I'm going to do instead is I just want to get this t out of the denominator. So this is divide by t. In order to get it out of there, I'm going to multiply by t, and I'm going to do that on both sides of the equation. That then will cross out these t's. They divide out. T divided by t is 1. 1 times all this still keeps it itself. So the t's cross out, and you're still left with the 2 pi over 9. Okay, now on this side of the equation, I need to multiply that t back into this fraction. So if it's hard to think of it as t times 5 pi, you can also think of it as t over 1. The t is multiplying with the numerator. So t times 5 pi is t 5 pi or 5 pi t. And that's how I'm going to write it. And then in the denominator, 1 times 27 is 27. Okay, we're now set up in a classic cross multiply setup. Again, they don't always have to be cross multiplying. This is just one way of doing it. So I'm going to cross multiply here first and then over here second. Remember, pi is not a variable. Pi is a number. It's a number that is exact, or goes on forever, infinite, it's approximately 3.14. So pi is not the variable. The variable is t for time. So I'm going to multiply that first. 5 times 9 is 45, but it's really 5 pi t times 9. So it's 45 pi t. Okay, next I'm going to multiply 27 times 2 pi, which will be 54 pi. Next, I'm going to divide by whatever's next to the t. Remember, I'm trying to get the variable by itself. So I'm going to divide by 45 pi. Divide by 45 pi. That's going to divide out the 45s. That's going to divide out the pi's. And on the right side of the equation, it's going to divide out the pi's. Okay, now I need to reduce this fraction if possible. If you are good with reducing, you may notice that both of these numbers divide by 9. 54 divided by 9 is 6. 45 divided by 9 is 5. So if possible, divide it out like that first. If you don't remember how to do that or don't do very well with dividing, you can certainly divide it in your calculator. 54 divided by 45. And then I can just hit math, enter, enter. Remember, it will reduce it for you. But it works out to be 6 over 5. And again, the reason is because both of these divide by 9. So you can reduce it that way. Okay, now the time of this one is minutes. So I'm going to say minutes. The last formula that you're going to work with is the linear speed formula. V equals the radius times the omega. So this is the given information. This is number 16 in the book. Okay, look at what's given. Radius, omega, that means we're finding the linear speed, which is v. When the r and w are right next to each other, that means we are multiplying them. So I'm multiplying the 8 times the 9 pi over 5. When I looked at the answers in the book, all of these questions are left in terms of pi and also as fractions in lowest form. So if you multiply these together, it's just 8 times 9, which is 72. And then you've got the 8. This would technically be 8 over 1 if you need to look at it that way. So 1 times 5 is 5. Check to see if that reduces. This is a V. Check to see if that reduces. You could try it in your calculator by taking 72. Notice how I'm not putting in the pi today. Divide by 5. You see it's a decimal. And then if I hit math, enter, enter, it's still 72 over 5. So this does not reduce any. It would just be 72 over 5. And then the book labeled this as centimeters per second. Okay, don't worry too much about the labels on these. We're just kind of practicing the labels on these problems. If you get stuck on a label, just look at the answer key and then label it appropriately based on what you see there. Okay, write down the assignment and then we'll take a look at number 6. So number 6 is that same type of question, and the directions will give you the formula to use. So you don't have to figure out which formula to use, it will be given. This one said omega equals theta, which is the angle, divided by the time. And in this case, you can see what's given and what we're trying to find here. So omega is given, so let's plug in the pi over 4. I'm still looking for theta. See how this is not theta given up here. And I'm still dividing by the time, which is given, it's 5 minutes. Okay, classic setup for cross multiplying. Again, it's not always going to be cross multiply. You may have to multiply a number to either side of the equation. You may be dividing, you may be flipping it over, lots of different things happening. Each question will be slightly different. Just remember that. 4 times theta is 4 theta. 5 times pi is 5 pi. The next thing you're going to do is get the theta by itself. So divide by 4. 4's divide out. And you get 5 pi over 4. You could try to reduce this, But if you try to figure out if anything divides into 5 and 4, nothing does. So this would be our reduced answer, and theta is our radians. So you could say 5 pi over 4 radians. Okay, so this is the assignment pages. Finish these up. Have a great day.